All right, now I'm recording. Okay, down here in the bottom left-hand corner, this is where we left off yesterday. That number that's right down there, what does that number stand for? What does that mean?
Number of protons.
Number of protons. Okay? Hold on a second. I gotta do that because otherwise you can't see the board. Okay, so that's the number of protons. And where do we find the number of protons? Cam, where do we find the number of protons? On the periodic table. So if we go ahead and we break out a periodic table, if I can find one here. Let's go here. Okay, reference tables. And I ask you how many protons magnesium has. Rotate clockwise. How many protons is magnesium going to have? Jacob? 12. Okay? That's why knowing the elements helps in this case, right? You didn't have to go and look up what magnesium was. So it's right here. Magnesium has 12. So if I go and I put in 12 right here, that is the number of protons. It's also called the atomic number. And it is also the nuclear charge. I think that's where we left off yesterday, talking about nuclear charge. Because there's only one thing in the nucleus that has a charge. And that thing is the proton. So that's why we can call it the nuclear charge. All right. There's one other thing that number stands for. And that is the number of electrons in a neutral atom. And neutral means it has no charge. So when I write down an atomic symbol, like magnesium, for instance, just like that, that is an atom. It has no charge. And so therefore, if I ask you how many electrons that magnesium has, what are you going to say? Angeli? 12. Because the number of electrons is equal to the number of protons if you have something that is neutral. So if we look back in our notes from yesterday, okay, protons are a positive one and electrons are a negative one. If it's neutral, they're going to cancel each other out. Okay? So when I write down something that has no numbers anywhere here, it might have a 12 here, but that number 12 talks about the number of protons, and it also tells you the number of electrons. Okay? All right, now let's deal with the number up in the upper left-hand corner. Okay? That number is called the atomic mass, or the mass number. Now, those are not the same. The atomic mass and the mass number are different from each other. Okay, let me explain why. I'm going to rewrite it on another piece of paper just so that I have it. Okay, you're writing it here. So this number right here, whatever that number is the atomic mass or the mass number. Okay, the atomic mass, where's my black pen? That number right there is the atomic mass. That is the mass number. What's the difference between those two? One's a decimal. Okay, you see that? And the reason why this guy is a decimal and this guy is not, so atomic mass is an average spell it right, average of all the magnesium isotopes. We don't know what isotopes are yet, but I'm going to tell you in a minute. Okay. The mass number is the mass of one atom. That's the difference. So this is the average of all the magnesiums out in the entire world. So let's think of it like this. Magnesium is a family. Okay? There's a grandma and a grandpa, and there's a mom and a dad and a brother and a sister and a baby. Okay? None of those magnesiums, grandma magnesium and grandpa magnesium and mom magnesium and dad magnesium, none of them weigh exactly the same amount. Okay? But if I take all of their weights and I divide it by how many people live in magnesium's house, I'm going to get an average mass of all the magnesiums. This mass number, this number right here, is the mass of one of the people. Okay, that's the difference. This is the magnesiums, all the magnesium. So if you go to China and you find a magnesium in China, okay, that mass of that magnesium might be 25. And then you go to Hawaii and you might find a magnesium with a mass of 23. If I take all of those magnesiums from all over the world and I average them, that's what I'm going to get. So on your reference table, if you take and you look at the magnesium on the reference table, okay, where is my reference table? There it is. Let's zoom in on magnesium. Okay, this is an atomic mass. It is an average of all the magnesiums in the world. If you're doing a problem and in the problem it tells you magnesium 24 without a decimal, then it's the mass of that particular magnesium. Capiche? Okay. We are going to learn how to calculate these later on, but I just wanted to kind of give you the overview right now. Let's talk about mass number. Mass number, which is for one atom, is the mass is calculated by the number of protons plus the number of neutrons in that particular atom. You can't see what I'm writing. Okay? So the mass number is equal to protons plus neutrons. So if we're looking at one atom and we want to know what its mass is, it's the mass of the protons plus the neutrons. So I'm going to go back here. I see some people still scribbling. You okay, Cam? Was that you talking or was that Sean? Question? These? They're not really equal. Oh, good observation. Yeah, most of the time they will be. What happens is as you get closer to the bottom of the periodic table, then they get less and less equal. Okay? And there's a reason for that. Just hold that thought for a second. All right, if you look at the mass, the only thing that's contributing to the mass of an atom are the protons and the neutrons. We already said that the mass of an electron was 0. So it makes sense that the mass is protons plus neutrons. Got it? Eva, right? Yeah. Got it? Okay. All right, let's go back to this. So, let's say I have a carbon with a 14 here. Okay? That 14 is representing the mass number, right? It's one atom and its mass 14. How many protons are in that carbon? Alex? 6. And how did you get that? Okay, so do you have one in front of you or you just remembered? Okay, so for those of you who don't have it in front of you, look. Here's carbon. Okay. Its atomic number is 6, and so therefore it has 6 protons. Okay. How many neutrons does it have? Not 6. Okay, it's not 6, because in this case it's not going to be equal. I made it purposely not equal. Well, we know that the atomic number is 6. This number up here is equal to what? Protons plus neutrons. And this number was protons only. So how, you can't see a darn thing. That's when you're supposed to yell at me. Be like, what are you talking about? No. So if this number is protons, you just have to be like, hello, you don't know. Because I'm not looking back there. I'm looking here. Protons and neutrons is the top number, and protons only is the bottom number. How do I find neutrons? Alex, go ahead, tell them. You're going to subtract them. So we're going to do 14 minus 6, and we're going to get 8 neutrons. Okay. In this case, the protons and neutrons were not the same. If I did carbon 12, then I would have 6 protons and 6 neutrons. You want to take a wild guess on how many electrons you're going to have? Okay. How did you know it was 6? What made you say it was 6? Is it a neutral atom? Okay, and in a neutral atom, let's go back here, the number of electrons in a neutral atom is the same as the number of protons, the atomic number, and the nuclear charge. So this case, 6 electrons. What about this case over here? How many electrons do you have over here? Not a trick question. 6. Okay. What did I do wrong? Oh, I know what I did wrong. Okay, here. 6 protons. That's this number. 8 neutrons. 14 minus 6. And 6 electrons. Electrons didn't change in either one of these. Okay? Carbon 14, carbon 12 are isotopes of each other. Our first I word of the year. There's a lot of I words. Okay. Isotopes. Come up with a definition of an isotope, knowing that these two are isotopes of each other. What do they have the same number of? Dylan? Perfect. Okay, so let's write it. Isotope. You need to have this down. They have the same number of protons, and they have different numbers of neutrons. Now, you might see it written like this. Same atomic number, because the number of protons and atomic number are the same, and different mass numbers. Same number of protons, different number of neutrons. Are these isotopes of each other? Jacob, what do you think? Are these two suckers isotopes of each other? How do you know that they're isotopes? What do they have the same of? Same number of protons. That's the bottom number. And different numbers of neutrons, which is the top number. What element is this, Mia? You have a reference table? Okay. Open up that periodic table and tell me what element this is. Go guess. Hold on a second. Let her look. Perfect. It is nitrogen. Okay, tell everybody how you did that because there's still some people out there who have no idea. Not atomic mass of 7. Atomic what? Not mass. Mass doesn't tell you what element it is. Atomic number is 7. So if you have an atomic number of 7, then you know you're dealing with nitrogen. Okay? Are these isotopes of each other? I'll put X's where they are. Can't see, can't see, can't see. Okay. Let's do 6 and 12 and 12 and 5. Are these isotopes of each other? Why not, Sean? Protons are not the same. Do you understand that, Maddie? Everybody good? Allison, you good? Okay. All right. So that's isotopes. Let me sorry. So you have 12 protons and 12 neutrons. If you add protons and neutrons together, you're going to get the mass number. All right? The atomic number is 12, so the number of protons is going to be 12. How many electrons is it going to have? Ashlyn? 12. Okay. All right. Zinc. What's its symbol, Sean? Z what? It's one of the 35 I said that you have to know. Zn. Good guess. Okay. All right, its atomic number is 30, so how many protons does it have? Diego, how many protons? 30. All right, its mass is 65. How many neutrons does it have, Lexi? Perfect. Okay, 65 minus 30 gives me 35. And how many electrons is it going to have? Ryan? Somebody help him out. Angela? What? 30. Tell him how you knew that because he doesn't know. Protons, wherever that is, right here. Look right here. And electrons are going to be the same. Protons and electrons in a neutral atom. And all of these are neutral right now. They're not going to be neutral for the next couple days, but right now they're neutral. All right, bromine, what's its symbol? Ava? Yes, ma'am. Br, what's its atomic number? 35. You can get that two ways. You can either look at your periodic table, which is right here, so let's find bromine. It's right here. Or you can say, all right, the number of electrons was 35. I know it's a neutral atom, so the number of protons has to be 35. And if the number of protons is 35, the atomic number is 35. All right, how many neutrons does this stinker have? Alex?
45.
45. Let's just make sure the math is right. 35 and 45 gives you 80. Love it. Okay. Kyle, you got this? You sure? Okay. What's the symbol for aluminum? Adrian? AL. Remember, when you see an A with a little line after it, that's an L, not an I. Aluminum and chlorine are the ones that are sticky for people. All right. We know that it has 13 protons, so its atomic number is also 13. What other number is 13? Jacob? We got protons. 13 protons. Atomic number is 13. What other number is going to be 13? Electrons. Beautiful. And then, what's its mass number going to be? Diego, go. 27. I like it. All right. Uranium. Who haven't I talked to today? Did I talk to everybody in here? I think I did. Ashlyn, uranium, what's the symbol? U. Maddie, how many protons does this sucker have? 92. And if it has 92 I wrote it in the wrong spot. 92 protons, then it also has to have 92 as its atomic number. What's its mass number? 54? No, that doesn't seem right. 50.
Good morning, everyone.
200 and what?
Please have everyone's attention. So as you know, each year we conduct 4 lockdown drills. And today is going to be the first one. Before we start moving into place, we always like to start our first drill by just talking a little bit about the process. Obviously, the most important thing to know for everyone is